look at chapter 5, which is the last section, the last chapter of this Cal 1. 5.1 is the natural log, alright, function. If you recall, then if you have an integral x to the n, is x to the n plus 1 over n plus 1 and then plus some constant c. And n cannot be 1. The reason that n cannot be 1 because if n is equal to negative 1, you're going to have, it should be negative 1. So because if you n equal to negative 1, you're going to have negative 1 plus 1, which is x to 0. That's no problem, but the denominator, we're going to have 0, which is undefined, right? So the definition here is if you have an integral from 1 to x, 1 over t dx, x is greater than 0, you're going to have ln x. Now, theorem 5.3 is just the reverse from here to here. If you take a derivative of ln x is equal to 1 over x. If you take the derivative of ln u here is an expression, you're going to have u 1 over u times du dx. Alright, so let's look at our example here. The first one, f of x is equal to ln 3x. 3x, think of it as u here. So I'm going to apply the second definition of theorem 5.3. Then I'm going to have my u would be 3x, and derivative of 3x would be 3. Reduce it, it's just 1 over x. Right? The second one, I have g of x is equal to ln x squared. So I'm going to rewrite this first, alright, as the natural log. I can write it as 2, I'll bring the 2 up, ln x. And then I will take derivative. So 2 will be 2, ln x is just 1 over x. So your answer will be 2 over x. Right. The next one, I'm going to take the derivative of ln quantity x to the 4th. So I'm going to bring the 4 up front. So I have 4 ln x. Now the degree will be 3. But then you have to take the derivative inside here, which is 1 over x. Then your answer is going to be 4 ln x to the cube over x. Right? The next one, I have f of x is equal to x times ln x. Now I have to use the product rule. So the derivative of this will be first, this is my first, and this is my second. First times derivative of the second, so first times derivative of the second plus second times derivative of the first. Derivative of the first is just 1. So if I simplify this, I cancel out the x. I end up with 1 plus ln x. Okay. Next one, I'm going to rewrite this as expanded form first. This is a single term, so I'm going to rewrite this as expanded form. When you have multiplication, here is plus. When you have division, here is minus, and then you can bring the exponential up front. So I'm going to rewrite this as ln x, that's your first term here. Because multiplication, I will have plus. I bring the exponential up front, so I have 2 ln x squared plus 1. Denominator is going to be minus, but I have square root here. Square root, if you change to exponential, it's going to be 1/2. So 1/2 2x to the cube minus 1. I forgot the ln. I have to put the ln. So minus ln 1/2 ln 2x to the cube minus 1. Right? Okay, now I rewrite it as expanded form. Now I can take derivative of each term. So the first term I'm going to have 1 over x from this theorem right here. The second term I'm going to have 2. Now ln x squared plus 1, think of it as u here, right? Think of it as u. So I'm going to have x squared plus 1, that's my u. Derivative of this will be 2x. Okay. The next one, I'm going to have minus 1/2. Think of this as u again and apply this one here. So I'm going to have negative 2x to the cube minus 1. And then derivative of this, which is 6x squared. Right? Let's see, I want to simplify a little bit. So this is 1 over x plus 2 times 2 is 4x, x squared plus 1. Maybe the last term I can reduce the 2 and the 6 here. So I end up minus 3x squared over 2x to the cube minus 1. Alright, let's see more example. Hi everyone, let's come back to our section 5.1. Alright, let's look at this example. They asked you to find the derivative of this expression and x not equal to 2. So when x is not equal to 2, then we don't have 0 on the numerator. So the whole thing is not equal to 0. So what I'm going to do, I want to find the y prime. I'm going to take ln both sides, alright? The first step I did, I take ln on the left hand side and take ln on the right hand side. I'm going to leave the left hand side alone. On the right hand side, this is a single term. I'm going to write it as expanded form. So I have here x minus 2 quantity square, so I can bring the 2 up front. So I end up with 2 ln x minus 2 parentheses. The denominator, if you write in expanded form, is going to be minus. That's why I have minus here. Square root is mean in the half power, so I rewrite it as exponential form, which is 1/2. So I put it here. Then ln x squared plus 1. Alright. Next step, I take derivative both sides. The reason I take derivative because I want to have y prime by itself. So if I take derivative of ln y, I will have y. Derivative of y is just y prime. On the right hand side, number 2 here is just number 2. ln x minus 2, think of this as u. So this is to u. Derivative of this is just 1. Minus 1/2 is just 1/2. Think of this whole term is u. So I have u on the denominator. Derivative this of x squared plus 1 is 2x. So I take derivative both sides. Next step I did is I distributed 2 in here. That's what I get here. And I reduce the 2 here, then I get the second term here. Because these two terms have different denominator, I find the LCM. LCM is x minus 2, x plus 1. So I make them the same denominator, which means the first term I'm missing x squared plus 1. The second term here I'm missing x minus 2. Next step I did is I distributed 2 in here, so I get 2x squared plus 2. Distribute the minus x in here, minus x squared minus 2x. The denominator remains the same. After that, I want to have y prime by itself because y prime is the derivative that I'm looking for. So I multiply both left and right side by y, so I end up with y prime by itself. That's what I want. So I have y here because I multiply by y, both sides. And then I have y, and this whole thing I simplify it. 2x squared minus x squared, I have x squared minus, it should be plus right here. Yeah, because this this. Alright, so I will get plus 2x plus 2 now. Uh, from here, it look like we stuck. We don't want to have y. We want to have y prime equals something that involved with x. So what I'm gonna do, I want to get rid of this y. Alright, so I substitute y equal to this whole expression right here. Y equal to this from the original equation to get rid of y. So then I have this whole term here. And then I simplify, I have x minus 2 quantity square, x minus 2, I reduce that, I have this just one term and everything else. Now, I have y prime by itself, which is the derivative of y. The last step is, it's not wrong if you don't rewrite it this way, but if you write it, it's okay too. So the numerator is the same. Denominator, this is x squared plus 1 to the 1/2, and x squared plus 1 to the 2/2. So it becomes x squared plus 1 to the 3/2. Either one is correct. Alright. Let's look at the next definition. You have an integral from 1 to e, 1 over t dt, that's equal to ln e, and equal to 1. Now, theorem 5.4, if you have take the derivative of ln of absolute value of u, you're just going to get u prime over u, which is pretty much is the same as just ln u. Let's look at this example. F of x is equal to ln absolute value of cosine of x. So my u is cosine of x. So derivative of cosine of x is negative sine x. So sine over cosine, that's tangent. So it's negative tangent of x. Alright, we finished 5.1. I'll see you next time. Bye.